A slow, haunting shot reveals the International Space Station, gliding silently over Earth's curved horizon at dawn, sunlight glinting off its solar arrays. The camera pushes in on a small white cylindrical module docked to the station's side, a Soyuz spacecraft. As we draw closer, we hear it, the subtle but growing sound of escaping air, like a tire slowly deflating. Wisps of crystallized air particles stream out into the black void. On August 30th, 2018, 6 people woke up 250 miles above Earth to discover something was terribly wrong. Somewhere on the International Space Station, their atmosphere was bleeding into space. Not from a meteorite strike, not from a systems failure, but from something far more disturbing, a tiny hole that would spark one of the most controversial incidents in the history of human spaceflight. The crew faced a race against time to find the breach before their home in orbit became uninhabitable. But the real danger wasn't just the leak itself. It was what that hole would reveal about the fragility of international cooperation in space, and how quickly decades of partnership can unravel when suspicion meets the unforgiving physics of orbital mechanics. The morning began like any other aboard humanity's greatest engineering achievement. The 6 members of Expedition 56 floated through their wake-up routine, conducting standard systems checks across the station's interconnected modules. These checks are the mundane heartbeat of life in orbit, monitoring pressure, temperature, oxygen levels, the 1,000 small details that keep humans alive in an environment that wants nothing more than to kill them. But this morning, something was off. In mission control centers in Houston and Moscow, flight controllers noticed an anomaly in their data streams. The station's atmospheric pressure was dropping. Not catastrophically, not even quickly, but persistently, unmistakably, the numbers were trending downward. Somewhere in the vast structure of the ISS, air was escaping into the void. The crew confirmed what ground control already suspected. They were losing atmosphere. The station was bleeding precious oxygen into space, and no one knew where it was coming from or how fast it was really happening. In the vacuum of space, even a small leak becomes a ticking clock. The question wasn't whether this was serious. It was how much time they had before the situation became critical. Imagine living in a house where one room is slowly filling with water, but you don't know which room, and you can't see the water because it's invisible. That's the challenge facing the crew. The International Space Station isn't a single room. It's a complex of modules built by different nations, launched at different times, connected like a 3-dimensional puzzle stretching the length of a football field. Finding a tiny breach in this labyrinth, while that breach slowly drains the air you need to breathe, requires methodical precision and nerves of steel. The crew began the isolation protocol. This is exactly what it sounds like, sealing hatches between modules one by one, creating airtight compartments, then monitoring which sections continue to lose pressure. It's detective work in microgravity, a process of elimination that narrows the search area with each sealed hatch. Module by module, they worked through the station's American segment, then the European lab, then the Japanese Kibo module. The pressure continued to drop. The search moved to the Russian segment. Cosmonaut Sergei Prokopyev, a test pilot on his first spaceflight, took point in the investigation. He floated through the narrow corridors with an ultrasonic leak detector, pressing the device against walls and listening through headphones for the telltale whistle of escaping air. In the silence of space, sound becomes your ally. Air rushing through even the tiniest opening creates vibrations that the detector can pick up, translating the invisible into the audible. The signal grew stronger as Prokopyev moved toward the Soyuz MS-09 spacecraft, docked to the station since June. The Soyuz isn't just another module, it's the crew's lifeboat, their guaranteed ride home in case of emergency. Every person aboard the ISS knows that if something goes catastrophically wrong, that cramped capsule is the difference between life and death. Prokopyev pulled back a decorative fabric panel inside the Soyuz orbital module, and there it was, a hole, tiny, barely visible to the naked eye, but perfectly, impossibly round. The discovery should have brought relief. They'd found the leak. They could fix it. The crisis could be contained. Instead, what Prokopyev saw sent a chill through the international space community that had nothing to do with the cold of space. Because this wasn't the chaotic, explosive damage pattern of a micrometeorite impact. Those leave irregular tears, petaled metal edges, the unmistakable signature of something traveling at thousands of miles per hour punching through aluminum. This hole was different. It was circular, clean, and around it, visible in the metal, were marks that looked disturbingly like someone had drilled it. Multiple drill attempts, in fact, as if someone's hand had slipped while trying to penetrate the spacecraft's hull. The implications hit like a physical blow. If this hole was manufactured, if someone had deliberately drilled into the Soyuz, then when? And more terrifyingly, who? To understand why this discovery was so explosive, you need to understand what the Soyuz represents. This spacecraft has been flying since 1967, making it one of the longest-serving spacecraft designs in history. It's been refined, improved, and proven through more than 140 crewed missions. When the Space Shuttle fleet retired in 2011, the Soyuz became the only way for any astronaut from any nation to reach the International Space Station. American astronauts, European scientists, Japanese researchers, everyone rode Russian Soyuz capsules. For years, it was the sole thread connecting humanity to its orbital outpost. The Soyuz consists of 3 modules, each with a specific purpose. At the top sits the orbital module, a spherical compartment that serves as a living space during the 2-day journey to the station. It contains supplies, a toilet, equipment, everything the crew needs during flight. In the middle is the descent module, the cramped, heat-shielded capsule, where cosmonauts and astronauts strap in for the violent re-entry through Earth's atmosphere. At the bottom, the service module houses engines, fuel, and solar panels. Here's the critical detail that would shape everything that followed. The orbital module, where the leak was found, is jettisoned before re-entry. It separates from the descent module and burns up in the atmosphere. This meant the hole wouldn't affect the crew's ability to return home. When it came time to undock and head back to Earth, they'd separate from the damaged section and leave it behind. But that was cold comfort in the moment, because the Soyuz had to remain docked to the ISS for months as the station's emergency lifeboat. And as long as it stayed connected, that hole threatened to drain not just the Soyuz, but the entire station's atmosphere through the interconnected hatches. On the ground, program managers faced an impossible calculus. Kirk Shireman, NASA's ISS program manager, and his counterparts at Roscosmos had to make a decision with incomplete information and lives hanging in the balance. Do they undock the damaged Soyuz immediately, leaving the station without full evacuation capability? Do they attempt a repair in orbit, something never done before on a docked spacecraft? Or do they order a complete evacuation, abandoning the $100 billion laboratory to an uncertain fate? Without a crew to maintain systems, perform repairs, and adjust orbital parameters, the ISS could become unrecoverable. Decades of scientific progress, international cooperation, and human achievement could be lost. The station might tumble, its orbit might decay uncontrollably, or critical systems might fail beyond repair. The clock was ticking, and every option carried catastrophic risk. The crew had perhaps 48 hours before a decision would be forced upon them. But Sergei Prokopyev and his fellow cosmonaut Oleg Artemyev weren't ready to give up. In Moscow and Houston, ground teams worked around the clock to develop a repair procedure using only materials already aboard the station. Space doesn't offer the luxury of running to a hardware store. Whatever solution they devised had to work with what was on hand. The answer came from an unlikely combination: epoxy, resin-soaked gauze, and Kapton tape. These weren't materials designed for hull repair. They were aboard for entirely different purposes. But in the improvised world of spaceflight problem-solving, you use what you have. The plan was to create a multi-layer seal that could withstand the pressure differential between the station's interior and the vacuum outside. Think about what that pressure differential means. Inside the ISS, the atmosphere is maintained at roughly the same pressure you experience at sea level on Earth, 14.7 pounds per square inch. Outside, in the void of space, there is nothing. Zero pressure. Absolute vacuum. That difference might not sound dramatic, but it's trying to push every molecule of air inside the station out through any opening it can find. Sealing a breach isn't just about plugging a hole, it's about creating a barrier strong enough to hold back that relentless force. Prokopyev and Artemyev entered the cramped Soyuz orbital module with their repair kit. Working in microgravity adds layers of complexity to even simple tasks. Liquids don't pour, they form floating spheres. Adhesives don't drip, they stick to everything, including you. Every motion has to be deliberate, controlled, because in the absence of gravity, there's no natural down to guide your movements. They carefully cleaned the area around the hole, removing any contaminants that might prevent the epoxy from bonding. Then, methodically, they applied layer after layer of resin-soaked material, building up a seal that would cure in the station's atmosphere. The epoxy they used was a specialized compound designed to harden in these conditions, creating a pressure-resistant barrier. The repair took hours. The world watched, or at least, the small community of people who follow spaceflight closely watched, as two cosmonauts performed emergency surgery on their spacecraft, while hurtling through space at 17,500 miles per hour. And it worked. Pressure stabilized. The leak stopped. The atmospheric sensors showed the station was holding its environment. The immediate crisis was averted. 6 people could breathe easy, quite literally for the first time since waking up that morning. But success brought questions, not answers. Because now that the hole was sealed and the station was safe, everyone wanted to know, how did this happen? The forensic analysis began immediately. High-resolution photographs from orbit were transmitted to the ground, where engineers and investigators examined every detail. What they found was disturbing. The images showed not just one drill mark, but several. It looked like someone had attempted to drill through the hull multiple times, slipping or missing their mark, before finally penetrating the metal. Around the hole, there were traces of sealant, evidence that someone had applied a temporary patch, perhaps hoping it would hold long enough to avoid detection. This is where the story transforms from a technical incident into an international controversy. Dmitry Rogozin, the head of Roscosmos at the time, made a statement that sent shockwaves through the space community. He suggested the hole had been drilled intentionally and announced that Russia would investigate whether it happened on the ground during manufacturing or, and this is where things got explosive, in orbit. The implication was clear. If the hole was drilled in orbit, someone aboard the ISS had committed sabotage. Russian media ran with the story. Speculation exploded across news outlets and online forums. Some reports suggested that a NASA astronaut suffering from psychological stress might have deliberately damaged the Soyuz. The theories ranged from the merely unlikely to the utterly absurd, but they all shared a common thread. They accused the international crew of the ISS of betraying the trust that holds the station together. The reaction from NASA and the broader space community was swift and furious. The idea that a trained astronaut, selected through years of rigorous psychological evaluation, would deliberately endanger their own life and the lives of their crewmates was not just offensive. It was technically nonsensical. The hole's location, the pattern of drill marks, the presence of failed sealant, all of it pointed to a manufacturing error on the ground, most likely at the Energia factory in Russia, where the Soyuz was built. The most plausible explanation was human error during assembly. A worker drilled into the wrong spot, realized the mistake, and rather than report it, which would have meant scrapping an expensive component and facing consequences, applied sealant hoping it would hold. The Soyuz was tested, approved, launched, and docked to the ISS with that hidden defect slowly weakening until the sealant finally failed in orbit months later. But in the context of deteriorating US-Russia relations, following the 2014 Crimean crisis and years of escalating tensions, even a straightforward manufacturing error became fodder for geopolitical conflict. The International Space Station Partnership was one of the last remaining areas of cooperation between the two nations, and now, even that was under threat. Congressional leaders in the United States questioned whether America should continue relying on Russian spacecraft. Russian officials hinted at withdrawing from the ISS program entirely. The 6 astronauts and cosmonauts in orbit, colleagues who trained together, worked together, and trusted each other with their lives, found themselves pawns in a chess match being played by politicians and media outlets far below. Life aboard the ISS continued, but under a shadow. Daily operations went on, scientific experiments, maintenance tasks, exercise routines, but with constant monitoring of pressure levels and the integrity of the repair. Every shift, someone checked the patch. Every day, ground controllers analyzed atmospheric data, looking for any sign that the seal was weakening. Behind the scenes, ground teams developed plans for an unprecedented spacewalk to inspect the Soyuz exterior. This would be no routine EVA. The cosmonauts would need to navigate outside the Russian segment with specialized tools, position themselves to examine the exact location of the hull breach from outside, and collect samples that might provide definitive evidence of when and how the damage occurred. The spacewalk itself became another chapter in the saga. Months later, in December 2018, cosmonauts Oleg Kononenko and Sergei Prokopyev conducted the external inspection. They cut away sections of the Soyuz's thermal blanket and insulation to expose the hull around the repair site. They photographed the damage, collected samples of the sealant and surrounding material, and brought it all back inside for analysis. What they found confirmed what many had suspected. The evidence pointed overwhelmingly to a manufacturing defect that occurred on the ground before launch. The investigation would eventually conclude that the hole was indeed drilled during assembly, covered with sealant that wasn't designed for the vacuum of space, and the defect went undetected through quality control processes that should have caught it. But even with evidence in hand, the controversy never fully died. Some Russian officials continued to suggest alternative explanations. The complete investigation results were never made fully public, leaving room for speculation and doubt to linger. For the crew, the experience became a lesson in something that every astronaut eventually learns. Absolute certainty is a luxury you cannot afford in space. They would never know for sure if the patch would hold until they undocked for re-entry. They had to trust the repair, trust their training, and trust each other, even as people on the ground questioned all three. This acceptance of calculated risk is woven into the fabric of spaceflight. NASA's approach to risk management involves comprehensive systems for quantifying danger, assessing probabilities, and making informed decisions in the face of uncertainty. The ISS operates with multiple redundancies, backup systems for backup systems, precisely because spaceflight is inherently dangerous. There are single points of failure that could doom the station. Everyone involved knows this and accepts it as the price of pushing humanity's boundaries. The 2018 Soyuz leak revealed something profound about our presence in space. We are fragile visitors in an environment that offers no second chances. A 2-millimeter hole, barely visible, smaller than a pencil eraser, nearly forced the abandonment of humanity's greatest orbital achievement. The margin between success and catastrophe is measured in millimeters, in the strength of an improvised patch, in the trust between nations who sometimes struggle to trust each other on Earth. But the story also revealed something else. Human ingenuity and cooperation can overcome even the most daunting challenges when the stakes are high enough. 6 people from different nations, speaking different languages, representing countries with complex and sometimes hostile relationships, worked together to solve a problem that could have killed them all. Ground teams in Houston and Moscow, despite the political tensions swirling around them, collaborated to develop a repair procedure that saved the station. The Soyuz MS-09 eventually returned to Earth as planned, with the damaged orbital module burning up in the atmosphere just as designed. The crew came home safely. The ISS continued its mission, orbiting Earth 16 times a day, a testament to what humanity can achieve when we look up instead of at each other. Today, the incident serves as a reminder of both our vulnerability and our resilience in space. We've built an incredible outpost in orbit, a laboratory where the borders that divide us on Earth dissolve in the shared experience of seeing our planet from above. But that outpost exists on a knife's edge, maintained by constant vigilance, international cooperation, and the courage of people willing to live and work in an environment that is fundamentally hostile to human life. The hole in the Soyuz was eventually traced to human error, a mistake made on the ground, covered up, and discovered only when it threatened lives in orbit. It's a sobering lesson about the importance of accountability, transparency, and quality control in spaceflight. But it's also a story about problem solving under pressure, about people rising to meet a crisis, and about the resilience of international partnerships even when tested by suspicion and politics. As we look toward humanity's future in space, permanent lunar bases, missions to Mars, commercial space stations, the lessons of 2018 remain relevant. Space doesn't care about our political differences. It doesn't respect national boundaries or geopolitical tensions. It simply is, beautiful, vast, and utterly unforgiving. Our survival beyond Earth will depend on our ability to work together, to trust each other, and to maintain the systems and partnerships that keep us alive when we venture into the void. The 6 people who woke up that August morning to discover they were losing air didn't have the luxury of political posturing. They had a problem to solve, and they solved it. In doing so, they reminded us that despite our differences, despite the conflicts and controversies that divide us, we are all fundamentally the same. Fragile beings on a fragile spacecraft, doing our best to survive and thrive in the infinite darkness. That's the real story of the hole in space, not the mystery of who drilled it or why, but what happened after it was discovered, how people responded, how they worked together, how they persevered, and how, in the end, they won. If you enjoyed this story, hit subscribe for more stories where history, technology, and human ambition collide. Thanks for watching.